Hello everyone, Assalamu alaikum. Welcome to back our YouTube channel. In this session, we are going to learn about the troubleshooting of S7300 PLC. And in the machines, how can we interface with the PLC and in our laptop? How do we communicate with the PLC software for a troubleshooting purpose? We in this session we are learning about this and how can we interface about the PLC and in our machines. That's also we have to discuss in this session. So let's start about our discussion. Now, which machine we are troubleshooting? That machine name is foaming plant machine. The foaming machine plant, there we are using two type of machineries. One is wet part machineries and another one is dry part machineries. So the wet part function is itself it is working by using the chemical functions he handle, and the dry part functions is also separately he is working as itself, and he did some of the operational works. Some of the functions he did itself to make as mold functions he made operating. And wet part and dry part, there is some of the communication signals to handshaking signal. Some of the times when dry part is make it ready, then wet part give the signal to the dry part to make you ready. And when dry part is ready, then he give a feedback signal to the wet part to do his operational works for itself. If there is some of the alarm issue, then he give some of the signals to dry part. Might have some of the signal, might have some of the issues, so you have to stop yourself. So he give the signal. These signals we may call handshaking signal. So this handshaking signals, wet part and dry part, both itself is going on. And in my plant there has some of the issue dry part and some of the issue for wet part also. So how can we solve the issues that thing I am discussing in this session. First, now I am explaining in the dry part there are some of the operational issues we checked first. Then we did in the programming software side to check the parameters, hardware parameters and software parameters, it's okay or no. Or we interface some of the operations to check at itself it's some of the mismatch signal are going on. So some of the signals is working as properly, but some of the signals is not working as properly. So why it's not working as properly, that there's things we are discussing, there's things we are finding in our machineries. So these things how can we solve and how can we communicating each other, there's things I explain you to all as clearly in this session. And first I want to tell there are some of the protocols are using in these machineries, the dry part and wet part both. There some of the sections we are using master PLC and some of the section we are using slave PLC. The master PLC is making communication with each other. The dry part is ready or wet part is ready. There's inside some of the signal is going on in the master PLC. So master PLC give the signal to wet part, you make ready, and dry part to give the signal you make ready. So when the dry part and wet part both are communicating with using master PLC. So master PLC is the PLC he handle both dry part and wet part both. Now what's the protocol is going on, that's I am explaining to you now. In the foaming plant we tell there has two station. One is wet station and one is dry station. In the wet station we tell there has he deal on only the chemical quantity and chemical pressure and chemical functions he deal. This is the wet station, I may explain. This is the wet station. This is the wet station and another one is dry station. I may call here, this is the dry station, I think here 5 station. This is 1, this is 2, this is 3, This is 4, and this may call number 5 number station. This we may tell dry station, DRY, dry station. So what's the function to each station? The wait station function is he deal only chemical property. He deal chemical pressure is okay, chemical quantity is okay, and chemical ratio is okay. He deal only these three component. I mean, suppose in our plant there we are using three chemical. One we may call ISO, one we may call polyol, and one we may call C5. These three chemicals. Suppose different quantity in needs in the work station in the foaming plant. So how many quantity or how many ratio we want to send to the dry station, these functions this weight station deal. I mean chemical flow, chemical pressure, chemical quantity, these all functions deal in the weight station. So there has a specific PLC to operate or handle these functions. Okay, and in the weight dry station there is a specific separate station, and all separate station there is also separate controller or separate PLC. So this weight station and this dry station communication protocol, how to go, this communication protocol, now let we discuss. Here we are using a master PLC. Here we are using master PLC. This master PLC, he deal the functions of wait station and dry station functions he deal. If the wait station function, some of the things, some of the sections is okay, then this wait station function he communicate with master PLC. He directly not communicate with the dry station's PLC. So suppose this wait station is everything is okay and everything is fine and everything is healthy, then there has no making any alarm or many his status is good. Okay, then he sent a signal to the master PLC. His status is okay, everything is fine. And the dry station, if we want to do something operational works in that dry station, the dry station first he prepare to ready to make the station as operational. Then this master station give this dry station give a signal to the master PLC. He is ready to make operation. Then the master station he also give a signal to the wait station. If the wait station is okay and ready, then he give a feedback signal to the master station, and master station the feedback signal give the dry station. Wait station is ready to do his operation. You can do or you can operate yourself. Then the dry station do his operation finish. Then the wait station give his signal to do make it ready and make the operation as completely. Here the master station PLC to give this PLC a cable by using MPI cable. That's we discussed before. And this MPI protocol or Profibus communication cable is going here. Also, then a cable, Profibus cable, come from here, and then 1 to 2, 2 to 3, 3 to 4, 4 to 5, all communication cables are completing. If number 5 station we want to do something, then the communication protocol via the communication Profibus communication, the master he understand a dry station want to make it operate. Then he give a signal to the wait station give a feedback signal to the dry station, and dry station do its operation. This process operation are handling like this. Now we are discussing about the troubleshooting on foaming plant using S7300 PLC. This is Engineer Imam Hassan, Electrical Maintenance Manager, Al Jahid Group KSA. And here we are using, this is the main PLC or this is the master PLC of the foaming plant, and here we may use the wait station of the foaming plant PLC, and this we may call this is the dry station PLC, and these all are the dry station PLC number 1, number 2, number 3, number 4, like this. Suppose here some of the operations we want to do some of the operation, then he give the signal to the master station via MPI communication protocol using the Profibus cable. Then the wait station receive his signal. He want to do his operational work. Then he give a command signal to the wait station PLC. The wait station PLC, if there is some of the issue or some of the alarm, then he give a feedback signal to the wait master station PLC. Then master station PLC cannot operating or cannot handling to send the signal to the dry station PLC. Wait station PLC is not ready, or wait station is not ready to read the operation, so he stop the work. Then when master wait station is full ready to did his operational work, then he give the signal he is ready to handle the wait station. I mean the chemical property is okay, chemical flow is okay, chemical pressure is okay, chemical temperature is okay, all things when it is okay, then the wait station, then he give the signal, he send a signal to the master PLC, and master PLC did his operational works. Then he give the signal to the dry station. Dry station then make it ready, and wait station and dry station did their operational work to make complete to the flows. And here I am showing the network skin of the dry station and wait station. This is my master station PLCs. Here all input output modules are here together in the master station. Via the MPI cable or MPI protocol, this signal will go master from master PLC to go to the slave all PLCs. All are slave PLC, and this is the master PLC. This is number 1 station PLC. This is number 2 station PLC. This is number 3, 4, 5. All stations are are the dry station PLC, and this is the wait station PLCs, and this is the master station PLC. When wait part is ready, he give the signal to the master station. When dry part is ready, he also give the signal to the master station. Then each of the machineries did their operational works after confirmation of the master station. This is the network skin here is explained to all. And here we are using the hardware connection skin. Hardware in each station or each of the cabinets, what type of PLCs are there or what type of PLC modules are there. This my CPU or central processing unit of the PLC. Here built in together of the CPU, there has a 16-bit input and 16-bit output point, and this is the analog input module, this is digital input module, this is also digital input module 32-bit. This is the 32-bit digital output module 0.5 ampere, and these two are also digital output module 2 ampere. These modules order address is like this, and this is the input address. This we need the input address for maintenance purpose. This input address and output address is first need to finding which type of inputs are using here. Suppose in the PLC there are different type of inputs we are using. Some of the selector switch, some of the push switch, some of the emergency switch, sensors, proximity sensor, photo sensor, limit switch, different type of input connection we are did here in this address. And here this is the output address. This output address with different type of functions we are connecting, like relay, magnetic conductors, valve, flow meter, different type of output we are connecting from here, these operations. When this signals is okay, then he give the signal to the processor. He give a command to he is ready to do any operation. They do in the program. With respect of PLC programs, he give a respective of input commands, he give the signal to the output commands. Output should be ready, output should be run. This type of hardware connections are will did. Now in the program, how can we did or how can we solve our problem or troubleshooting our problem? Now we are going to the programming side. Okay, let's start. Now we are seeing the programming side. Opening the Simatic manager. First, we will see our backup program. This is Simatic Manager version 5.7. Set PCBG need to be changed here. This should be our cable is MPI cable, MPI A2 cable. We are connecting our MPI A2 cable active mode. Then okay, it is our backup program. It's some modifications are there, so we should not be re-download it. So we select it no. We from our backup program we have to see our the comments. We need to see the comments only, and then we will go to the main program. Now we reference data we have to see because of we need some of the input output tags. Display, then the reference cross reference data will come. This all are the if you want to found any input output address, then later we check by reference data. They are mentioned all input output address, which locations that inputs are there or that output are there or that memory flags are there. By using we by using the reference data cross reference check, then we can check all of the input output network address. From here we seen our I 14.1 in which locations are there. We seen from here Q Q 14.1 and Q 14.3. Then we go again in the program side. Q 14.1 is our jig up down. I mean, which options is not working properly. That output we first found. Then we are seeing the logic, which logic is active. Then this output will be on and our problem will be solved. First of all, we have to check the logics. Then we have to apply the conditions for respective view of input address with respect of output. This is the procedure for checking the input output address. Then we are trying now we are trying to now we are trying to make a new program. Then I will upload the existing program. We got our reference data. Now we are checking from here to upload our new program. Upload destination PG, then view to finding the CPU address by using MPI A2 cable. Then OK. Now program is uploading from my PLC. Here our problem area is there, FC1. For this reason we are entering our FC1 block. Now we want to go the network address 17 12. Here we found that address. See, now I am going to monitor mode to check the input output the logics, which one is on and which one is off. See, it's a green condition, which one is in green condition, that one is on, and which one is white, that one is not on. Here we found the 4.3 I4.3 there, that was a limit switch. That limit switch is not usable in our case. In our operational purpose we not used, but it is in here normally, or it is always on condition mode is coming, but it should be normally open, but the limit switch is stuck. He give the signal, PLC give the triggering signal. For this reason condition is not isn't run. In this case we check physically in our limit switch and want to disconnect or want to contact open in the limit switch. The limit switch is now is triggered mode, on mode. I 4.3. We found I 4.3. That was the issues that we solved. Yeah, now in this situation, now I disconnect the limit switch and connect again. And now we've seen I 4.3 is blinking. That means the limit switch is not before working properly. Now it's working properly. Now we are trying to run our machine, but there has some of the issue for T6. T6 is not run, not on. For this reason, we may see here jig operation is not working, but not working properly. It's high speed mode is on. Our jig has two condition is on. One is for fast forward and one is slow forward. Normally we run our machine slow forwardly. Yeah, but here T6 is normally stop for this region. It's working fast mode on faster run. But for this region, our problem is not solved yet. Now we are checking to another thing for how to run the T6 that we are checking. First, we have to see in our backup program the comments T6 is what's the condition for T6. Now we are seeing here. This is the T6. T6 is a depend on some of the sensor or limits, I4.7, I4.2 like this. Now we have to understand what's the limit in which area locations that limits are giving the signal. I4.2 here on. T6 give a signal. T6 is on. We see it here. Then finally, we seen our problem is one of the limit switch. That limit switch we stack on and off. We did that one on and off. Then the T6 is working properly. Now finally our problem is fully solved and our jig is run slowly moved. Our jig is running. Now we seen here that is our condition is on I14.3. For this region we seen our jig is up and down as working properly. Finally, Alhamdulillah, we got a good result from our side. Thank you everybody for watching and take times with us. We are really happy, feel happy. You are all with us. Again, thank you.